Oh, this is this is poorly prepared. Does this work though? Hello, hello, hello. Oh, it's really, really quiet. Okay, that's interesting. Maybe that's just my volume. It's just my volume. Cool. Okay, you can hear me, but number one is I forgot to change the episode, so let me just do that. Machine learning with biology in mind. PyTorch sounds good. Yeah, and that image needs to change. So let me just change that whilst I can. I love being prepared. It is the only way. Yes, yes, yes. What episode are we on now? We are on 13. Wow, okay. Right. File, export. Sorry, I should have just stopped the stream, really. Episode 13. Save, and then upload. Cool, I think that'll do it. Alright. So as normal, we'll start the stream with a little Duolingo for the Greek, because Greek seems to be everywhere in mathematics. So let's go ahead and do that. CO. Sigma. Yeah, that makes sense. Stare. 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 Sin. Sigma and the V for the N. Cool, makes sense. Which of those is to the cinema? To. Oh, what is that one again? That's an M. To mu seo. Okay, that makes sense. Cool. To museo. Oh, okay. Oh yeah, cinema, right. Mu seo. Museo. Oh, Torsio. To cinema. Ah, cinema, right. Okay. Don't know what I was doing then. The museum, okay. To museo. To museo. Cinema, okay. Stare would be stare. Stare. Match the pairs. That's me, me. This would be snore, and this will be a sigma. Snore. Then you've got seo, seo, seo. Sin, sin, stare, stare. Select the correct characters for seo. 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 Okay, I won't forget that. Select the correct characters for sin. 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 Which one of these is a cinema? Cool, we got it. Alright, alright, alright. Cool. That's that done. So from the last episode, we were just looking through the remainder of the getting started guides in PyTorch. PyTorch is an AI machine learning mathematical set of tools to manipulate things called tensors, and tensors are multi-dimensional arrays essentially. I think that's what I remember. And then yeah, I really haven't got any ideas as to what my first step into this is going to be, but the whole aim of this this broadcast or this learning is to create some biological programming inside the DNA to give function where function did not exist before. And I heard someone call it gainer function. So the DNA gains a function, or the protein gains a function. I think that's what that means. So essentially, it's that. It's just trying to. So the bigger aim is to. Um, so if people like Neuralink, so Elon Musk's Neuralink, are going to embed brain interfaces into our heads, then I think that some biological buffers will be needed in order to do that. So I would like to be on the train whereby we try to engineer our DNA to be more open to symbiosis with technology, A, or B is to essentially manipulate genetics to enhance us or give us capabilities to be able to do interstellar travel, because I'd like to give human life a longer life. So obviously when we get off this planet, because of, I know, comet comes or some existential disaster, then I want to say we're ready, because we have the ability to manipulate genetics to allow us to do longer travel. There's more to it, but the kind of guide is a little hazy at the moment because I'm not quite sure how that's going to work yet. But anyway, that's setting it. So just starting from square one, the original episodes were about learning a little bit of chemistry, a little bit of biology, pretty much GCSE grade because I can't remember any of it. And then and now I'm entering something a little bit more understandable for me, because it's around like engineering computer systems, but it's AI and PyTorch in particular. And there's another one called TensorFlow we might have a look at as well to kind of compare the two. So that's what I'm doing now. Right, okay, with that all said and done, because I haven't said that before, well, I haven't said it for a while now, so you might watch and think, what is this about? That's what it's about. I hope the stream gets better quality. Because at the moment it's all very blurry, isn't it? Let me just see if I can figure what's going on here. Maybe it's just me. Oh yeah, it's fine. Okay, cool. Right. So, where we left off was, if I go to my OneNote, episode 12, let's get a new one, episode 13. We go back to 12, click here to see page, nope. Delete config page. Right, cool. This is the place where we left off. Let's do this. So, optimizing model parameters. Now that we have a model and data, it's time to train, validate, and test our model by optimizing its parameters on our data. Training a model is an iterative process. In each iteration, called an epoch, the model makes a guess about the output, calculates the error in its guess, loss, collects the derivatives of the error with respect to its parameters. So my understanding of derivative is for a graph you're giving the angle of the slope. So that is the derivative, like how steep is the slope. So I mean, let me just try and understand what's being said here, because I think it's very important to kind of grasp these things. So let's say it says training model is in each iteration called an epoch. The model makes a guess about the output. So let's say the output's going to look like this, and let's say that this is looking at an image and is trying to understand what the image is, and this is the graph that it's kind of output based on the numbers and all the processing done. I don't know enough about it, let's find out. And then calculates the error in its guess. So I guess it compares it to the training data. So maybe this is the training data, and it's a bit like this, a little bit offset or something. Maybe it's a little bit steeper here. Kind of follows most of it. So then it would go, okay, so this is the loss. Collects the derivatives of the error. So I guess this is like we're measuring the slopes of these, you know, with respect to dy over dx. versus this, I guess, and then you would take some kind of dot product to measure the angle of this. So this would be the dot product between these two vectors. So this is v1, v2. It would be v1 dot v2. Wow, where's my dot? There, something like that. Yeah, so I think that's how this works. So this is what this is saying. And collects the derivative of the error with respect to its parameters and optimizes these parameters using gradient descent. Now I don't know what gradient descent is, apart from there's these kind of algorithms that allow a reshaping of a graph, and I suppose that you're saying, well, these are just guesses, what is it that I can do to this graph to make a better assumption about the model coming back, to avoid this loss or to get closer to the correct value from the loss. That's the part I don't know, and this is a lot of training going to have to happen. For a more detailed walkthrough of this process, check out this video on back propagation from 3 blue 1 brown. And we know 3 blue 1 brown. That's amazing that they've got him here, and I think we should take a look at it together. So let's do that.
One plate at a time. Sainsbury's.
Oh, you know what? I don't know if I can actually. Let's just have a look, because I have watched this before. Essence of calculus is, yeah, getting the change over time. Let's see, the chain rules in networks. So essence of calculus. So this is saying that dy over dx is the change between every single part of the line, and then obviously the smaller the change gets, you run to infinity, so it's like infinitely precise line. It can be expressed as an equation, and that's calculus. Let's see. So these are, I guess, some kind of middleware part. I don't remember what the name is for it. Gives you an output of a value of 0 to 9, and then that value gets fed back through into the whole thing, maybe n times, and then it keeps working out based on the model or the training data and the evaluation of that training data, the how to get this loss closer to 0 or whatever the number is, and then that's the output, I guess. I need to do that. And then let's see. Yeah, it's just like the function of all these w. I wonder what w is. Well, we'll have to. No, I don't know if I'm allowed to watch this. I won't do it. Desired output of 1 gets closer. There's a cost function. Okay. Z equals w to the power of l, a to the power of l minus 1, l minus 1. That's okay. So the exponent's getting smaller. Plus, I don't know the significance of this, so but it looks like z as a exponent of loss. Okay. I can't remember any of this. Fine. So the chain rule in networks, right? Okay. Excuse me. So the chain rule is the chain. Is this delta? I can't remember now. C0 equals 0 divided by the weighting. So this is cost over weighting maybe, and then as an exponent of loss equals change z. So dividing whatever this is by this, dividing it, so it's going to get, and it's got an exponent, so it's going to go down, and then you're timesing it by, it's really hard to see. Okay, fine, let's see if it gives us a graph after. Nope. Okay, I'll have to go through this myself, I think. some of it's coming back to me. Sum over layer L. Oh, layers L. Okay. So how many layers there are depends on. So this is the so j equals 0 to the sum of layer minus 1. So you're going back through them. N layer minus 1. Pass this through. Okay. Wjk to the exponent L. Jk is this kind of reference to kind of dimensions or something, isn't it? Oh man, I need to watch this again. Oh, this is interesting. So this, yeah, okay. This is showing the routes that it takes over and over again, because it keeps going through that function until +1, -1. Oh, it's really difficult to tell. So this might be that dimensionality, because I wonder if the I, J, and K, or at least J and K here, Z, J, and K, might be to do with if you put it on a grid like that. I think we talked about this once before. Imagine the axis like this, and then you've got like this, like almost topographic geometry here, and yeah, oh yeah, here we go. I remember now. Yes. So this, I think this is maybe this is the loss or the cost or something like that, and you basically are trying to find the best way down to the deepest points of the kind of geometry, because this is where you really want to sit. But then if you get too close to it, then it's overfitting data, and so it's not like wide enough to. I don't know, there's lots to it. So I need to watch this again so I can summarize it to you guys better. But definitely go and watch this. 3 Blue 1 is amazing. He's absolutely amazing. Okay, let's imagine we know this. We load the code from the previous sections on data sets and data loaders. Cool. And build model. So this is us doing that. Let me see if I've got this code already. Prerequisite code. Every good time I start this, I start yawning. It's not a good sign, is it? Where are we before? We were doing run autograd. Okay. Well, I guess let me close all this up. Whoa. I actually can't remember how to do this again. Collapse all PyCharm. Always forget the shortcut. Control Shift numpad plus and minus. Okay. Right. Let's put a function here. Run optimizing model. We'll just plop this in here. Nice. Don't need that, because it's already imported at the top somewhere. Oh, we'll just keep it there. So the training data is from the fashion and this stuff, so it's going to be like trousers and whatnot. One's training, one's not. It transforms it to those multi-dimensional arrays. I have no idea how it does that. Then we've got the data batch size of 64. Okay, training data comes from there. Test data comes from there. We've got a neural network class, and we're newing up that neural network class. In fact, maybe I should just torch the rest now. I think this is all completely useless to me, really. Don't need any of it. It's old hat. Yeah. In fact, I can probably just plot this up here now. Nice. Get rid of all this. Nice. And this stuff, don't need that. Just delete this. It's all in the history anyway. Don't need this. This is a complete waste of time, but I was trying trying to get used to Python a bit, to be honest. Don't need the data. And then neural network, don't need that. Oh, actually, I don't need that, yeah. Delete. Okie dokie, right. Okay. So if I run this is run optimize model, and hit the go button, what do I get? Probably get a load of errors. Interesting, I don't get anything. Oh, downloading, nothing output. I wonder if it even gets here. Why are these blanked out? They aren't used. Yeah. Model neural network, but it's initialized, so it should do that. But this should be outputting that download data. Nothing in my log. Oh, because datasets is now empty. Okay, so let's go back to here. Datasets. Nope. Oh, import datasets. Okay, so it comes from this. Gotcha. Right. Train data loader equals cool. Test data loader. Why is that not reporting anything? Ay ay ay. You would think that I have to tell it like to output that, but then what? I don't like this. And then module neural network. Rectify linear something. Doing that, run optimize model. Yep, that works. And then goes to all here. Definitely gets here because this is where I am now. Model equals neural network. I wonder if I can print that out. Maybe that's why. Print model, sorry. Maybe that's what it is. Maybe if I print these out. Nope. Well, that's strange. I guess need to go back a bit to get that output because I'm not remembering why I'm not seeing it. Root is the path where the train test data is stored. Train specifies training or test data. Downloads the data from the input if it's not available at root. Transform specify. Oh, maybe it's because it's already downloaded. Not sure. Let's go back to quick start. Because this is saying I should see that as well. Data, false, true, to tensor. Okay, PyTorch not outputting download operations. Print shape. Oh, that's so annoying that I can't see that. I want I guess I can just go on without it, but I do need to understand how this, like, because if it fails, then I'll have no idea what to do. But anyway, let's just move on. So it's downloaded that shit, right? And then hyperparameters. Hyperparameters are adjustable parameters that let you control the model optimization process. Different hyperparameter values can impact model training and convergence rates. Model training and convergence rates. So I wonder if the convergence is like the dot product becoming closer to 1, or I suppose -1, I guess, if it's a dot product. Or maybe it needs to be orthogonal. No, that would make sense. No, would that make sense? Yes, it would. It would make sense. So if the vector 1 and vector 2 were 1, then that means they are perfectly in line, facing the same direction, and so they should match. I wonder if that's what the convergence is. So it says the hyperparameters are adjustable parameters that let you control the model's optimization process. Different hyperparameters values can impact model training and convergence rates, like how close it gets over what period of time. Read more about hyperparameter tuning. Let's have a look at that. Close multiple tabs, close tabs to right. Read more. Hyperparameter tuning can make the difference between an average model and a highly accurate one. Excuse me. Often simple things like choosing a different learning rate or changing a network layer size can have a dramatic impact on your model performance. So by network layer size, I wonder if it's because if you give it more time to make more incremental, more incremental steps to convergence. So let's say there's like, I don't know, n equals 20 versus n equals 100, then this will make more mistakes because it has less time to query more, whereas this will make less mistakes because it has because it tries to query and converge slower, maybe. Fortunately, there are tools that help with finding the best combination of parameters. RayTune is an industry standard tool for distributed hyperparameter tuning. RayTune includes the latest hyperparameter search algorithms, integrates with TensorBoard and other analysis libraries, and natively supports distributed training through Ray's distributed machine learning engine. Let's have a look at that. Fast and simple distributed computing. Build any application at any scale. Ray is a distributed execution framework that makes it easy to scale your applications and to leverage state-of-the-art machine learning libraries. So initialize Ray, get some kind of handle on the remote. Okay, define a function of which takes I, sleep for 1 millisecond or whatever, and then return I after that. Futures is equal to an array of, so you call the function, you pass, that's interesting, define f as a, this is definitely a function. F.remote would be a property on the remote server. Where's I come from? For I in range 4. Okay, so I will be 0, 1, 2, 3. And you're outputting an array. And then ray.get, ray comes from the initialization of this object. Get the futures. Oh, no, get. Ray is a distributed execution framework that makes it easy to scale your applications and to leverage state-of-the-art machine learning libraries. What are we even looking at here? Tasks. actors. Class of count. So this, okay, this is Python, right? Oh, this is probably just very simple. People are probably looking at me thinking, "What the hell?" I'm not a Python developer, so it takes me a little while to figure out what these things do. I'm assuming that it makes a just an array of whatever. Let's have a look. Python online. Yeah, whatever. So if I do, I don't know, define f as a function of I, turn. Oh wait, what was it? Is this? I wonder if we can actually just do that. No, because it'll probably need Ray as a thing. So let's not do that. Time might be there though. Put time. Time.sleep. And then time.sleep for 1 second or 1 millisecond, and then return I. Okay. And then this one is going to be that, I guess. So futures equals fi for I in range of 4. Print futures. Just want to see what happens. File string line 7 define invalid syntax define. Yep. Got him. Hello world. Great. That's not what I wanted. Do this again. Ah, okay. Yeah. So after looks like 4 seconds. And let's just take that out. Yeah, so this just outputs an array, so this will run that function over that period and then return the output. And so Ray is a distributed execution framework that makes it easy to scale your applications and to leverage state-of-the-art machine learning libraries. Okay. I'm not sure not sure what that's saying, but okay. Right, I think it's a little bit too deep, so let's go back to here. In this tutorial, we will show you how to integrate RayTune into your PyTorch training workflow. We'll extend this tutorial from the PyTorch documentation for training a CIFAR10 image classifier. CIFAR10 dataset consists of 60,000 30 by 30 color images and 10 classes with 6,000 images per class. Okay, cool. And this one is got a pricing or something. Tutorials, product, any scale, key features, scalable, ready to get started, product. Okay, fine. So I guess it's just a. Let's see the open source. Tutorials and tips for the first time users. Ray provides a highly flexible yet minimalist and easy to use API. On this page we describe several tips that can help first time Ray users to avoid some common mistakes that can significantly hurt the performance of their programs. Alright, fine, whatever. Okay, so let's move on from here. What's the time so far? 30 minutes, okay. We define the following hyperparameters for training. Number of epochs, the number of times to iterate over the dataset, the batch size, the number of data samples propagated through the network before the parameters are updated. So let's take a picture of that. Put that in episode 13. It's a pretty good picture, I must say myself. Must say so myself, sorry. This one, on the other hand, is saying the number of epochs. So if you've got to n equals 0, n to 0, 0 to n, sorry, and then you've got, so that's epochs. Let's call this epochs rather than n. Whoops. Epoch. And then you've got the number of data samples propagated. Data samples propagated through the network before the parameters are updated. So this is as a function of parameters. Damn it. I need to go to the toilet. I'll have to stop this video. I'll do a 13.1 and I'll be right back in about, I don't know, 10-15 minutes because I might get beer as well. Okay, so